Morning, everyone. Thanks for joining us. We're going to start in about 5 to 10 minutes. We just want to let everyone settle in. If you guys have any questions, feel free to put them in the chat section under your control panel. For those of you who just joined, I just want to let you know that we're going to start in about 5 minutes. We just want to let everyone settle in. If you guys have any questions, feel free to put them in the chat section under your control panel. Good morning, everyone. Let's go ahead and start. Welcome to the Solar Battery and Storage webinar. This is part 6 of our webinar series that we've been doing. My name is Carly, and I will be your host today. John, if you want to go ahead and go to the next slide.
Oh, I'm sorry, I forgot to unpause my screen. There we go.
No, you're good. During this webinar, we just encourage you guys to take as many notes as you can. We're going to cover a lot of stuff, so if you guys have any questions, feel free to put them in the chat section, or if you want to shoot us an email after the webinar is over, you can do that also. We will be answering questions throughout the webinar and then at the very end. And then if you missed anything during the webinar, or if you want to watch it again, you will be sent the recording via email after the webinar is over, or you can go to our Enertech University page, and we have an online button to where you can see all of the previous videos, recordings that we've done, and you can watch it there. So John, you can go ahead.
All right, thanks, Carly. Good morning, everyone. We're going to cover the last of the solar, the 6-part series. If for some reason you missed any of the first 5, you can definitely go back to the our YouTube page or to Enertech University and click on that online video library, and you can check out any webinars that you may have missed, or later on this afternoon you can check out this one again. I know a lot of you guys sat through this already. Again, I'm John Pendleton. I'm the senior trainer at Enertech. If you need to contact me for any training needs, here's my email address. You can also email training@enertechgeo.com, or you can call either of those numbers and I can assist you with any of your training needs. Kyle Smith is with us here today. He's our solar sales and energy storage manager. He's been out on a lot of these jobs, and he pretty much started this solar stuff. So he's a great wealth of knowledge on that. So it's good to have him here. We won't keep you quite as long today. The battery one maybe is maybe about an hour or so today. So we won't keep you for the full 2 hours today. Again, our design team, any design help, we can definitely assist you. And as we go through this training today, there is some forms that need to be filled out, whether online or physically filled out, so we can size the batteries properly. And we'll cover some of those questions that we will need answered before we can actually size the batteries and the inverter and all that good stuff. So if you need anything from Design Services, that's their email address. You can also contact customer service if you need to order anything. That's their email listed there, as well as their direct, excuse me, their direct phone number, 664-9011. Again, we have residential and commercial offerings in the solar. We have job site deliveries, depending on where you're located, some of the utility services, installation support, obviously training, and we'll assist on your roof mounts or your ground mounts and just designing the solar array. So we're going to cover the storage and why we store energy, and the battery technology comparisons, integrating the battery and storage to the solar array or the PV array, and the design guide for that PV and storage. And we're using Fortress batteries. It doesn't really look like this big 9-volt battery, but we are using Fortress batteries right now. So why do we have storage? There's some challenges with the solar grid tie system. So there's times when you have unbalanced generation and consumption. So, you know, normally during the day, especially if you work, there's nobody there. There's nobody really using a lot of power, but you're producing a lot during the day because, you know, in the middle of the day, it's the sunniest time of the day. So you're producing a lot of energy. And so we can store that power that you create during the day and use it later on in the evening when you come home and turn your oven on, or the heat pump kicks on or something like that. So we can harness that energy, store it, and use it at a later time. You can also obviously use it if there's a power outage. You know, if you've got some battery backup, you can use it there. And in certain areas, we can't backfeed to the grid. So they're not going to buy your power back that you're producing from your solar during the day when you're not using it. I know some, I think maybe in the Cayman Islands, maybe even in Hawaii, I'm not really positive about that one, but they don't buy the power back. So there's no need to really produce it if you don't have anywhere to store it. So batteries are nice to be able to store that extra power that you would otherwise waste. So balancing energy generation and use. So obviously the energy that's not being used immediately can be stored in the batteries, and it'll match the needs and the demands, and it allows for grid resilience and backup power during outages. And then with these batteries, this whole array, the PVs, the inverters, the batteries, you can also put a generator on the system as well. And we'll cover a little bit of that, and you'll kind of see what it's all going to take. So basically, our energy storage in the market, they anticipate that it's really going to start growing. And you can kind of see, this is just a little chart from Fortress about the market growing from 2019 to 2024 by 12 times. So that's why we're starting to look more and more into solar and the battery backup. And this is just what we're using now. Things could change. We could find another battery manufacturer or keep this one and add another. Things are always changing in this solar, like we've kind of talked about before. So this is our first battery offering, and I'm sure in the future there will be other offerings available, especially as battery prices drop. You know, right now, especially, you know, they're newer to the ball game here, and so obviously pricing is up a lot more. I cannot really comment too much on the exact price of these batteries. I'm sure Kyle can maybe get into that a little bit later. So some of the energy storage benefits, so you can back up your home or your facility. So power your facility when the grid is off. It keeps solar panels running during an outage, and you can also run a generator more efficiently that way. It allows for self-supply. So where the grid prohibits feedback, you can use the batteries for your self-supply to your home. So kind of like an off-grid type setup almost, where you could have grid backup, but allow storage of your solar as well. You can maximize your PV production. So again, you store the excess solar power for later use. Obviously, it's going to save money on your electric bill because basically what you're going to do in these situations with batteries, if you've got grid, then you're going to charge the batteries during the off-peak times. So in the, you know, maybe in the early evening or the morning, and then when, you know, there's peak power times, middle of the day when it's really hot outside, we're not going to charge the batteries then because the grid power is more expensive. So basically we're going to also peak shave to lower the demand as well. Obviously there's some tax incentives by state out there. So definitely check out those incentives. I know in Illinois it was 30% last year. It's 26% this year, and then I think it drops down from there. But basically on the energy storage, you have your backup, self-supply, you got time of use, demand reduction, and then your off-grid as well. So here's a standalone solar array or PV array and a storage system. So if there's no grid available, you're off grid, you're out in the middle of nowhere, you don't have power coming in from the AC grid. So basically you have your modules, you have your inverter, which converts that power to usable AC power. And then you've got your battery bank, and then you can also tie a generator in if needed on that. So this would be more of a off-grid type setup here. A grid interactive application. So grid export with backup. Basically, when the grid fails, the hybrid inverter keeps the PV system operating and power loads from the solar array to the batteries. You can kind of see it in that little diagram there. If you've got the grid, when the grid is connected, the excess PV production will feed back to the grid itself. Again, here's that little bit better picture of the grid coming into the inverter, your PV modules coming into the inverter, and your batteries hooked up as well. The grid available for purchase, but sale is prohibited. So in other words, we're not selling back to the power company. So you can see in Hawaii, Arizona, and most of the Caribbean, they don't buy it back. So it makes a lot of sense to have the batteries so you're not just wasting power because you're going to generate it. So you might as well put it in some batteries. Basically, the PV power charges the batteries during the day and discharges them at night. When battery charge is low, power bought from the grid to supply loads and or charge the batteries, is depending. And the inverter controls and all that will take care of that situation there. So a grid export with backup and time of use. So that would be California. Basically, it's for peak shaving. It blocks out times for purchasing grid power. So, if the grid power, jumps up, let's just say 10 cents a watt during the middle of the day, we wouldn't want to charge the batteries during that time. We would prefer to charge the batteries when the power from the grid is a lot cheaper. So that's why we want to probably charge the batteries in the morning or in the evening, if possible. You could actually use it without even using solar. You could purchase batteries and pull from the grid in your non-peak times and bank it into the battery. And then in your peak times, pull from the batteries until the batteries get down to about 20%, and then go back to the grid power. So you could hook this whole thing up and not put the solar panels in as well.
A couple more notes on California. I mean, even with the fires that they have in PG&E that I was informed of recently, that actually it even serves as more frequent backups than you would think as well. And then in order to get batteries without solar, you will not be able to be qualified for the ITC tax credit, the federal tax credit. So if you want a tax credit with batteries, you need to get some PV, some modules with the system to be able to file for the tax credit. And you don't have to put in, if you have a 12 kW inverter, you don't have to have 12 kW or more of solar. You can actually get by with like a 4 kW array on that 12K inverter. So you don't have to have an equal amount of PV when you do that.
Cool. Demand curtailment. So basically you're going to reduce your kilowatt charger. It's more for a commercial clients, and it will require a smart control unit. And again, it will work without solar as well. It's kind of similar to the slide we just saw as well. These are the batteries from Fortress. They're lithium iron phosphate batteries. There's an 18.5 kilowatt an hour, 10 kilowatt an hour, and a 5 kilowatt an hour. So depending on what you've got set up will depend on which batteries you're going to use and how many of them you're going to need. So we've got the EFlex 5.4. So it does have a SD card for data storage, so you can track the battery inputs and outputs and that type of thing. There's also some Wi-Fi remote monitoring with the 5.4. And with this, it's pretty small, but so you can wall mount it. You can put it on the floor. You know, if you've got, let's say, 3 or 6 batteries, you can rack it. You know, one, you know, a shelf where you put one on top of the other. It's perfectly fine. You may even have a picture of it, of one that's racked up here coming up. But these are basically the technical specs and the capacities and the voltages and things. It'll let you know how many parallel stacking, if it's got LCD monitoring, communication and the type of communication, and breaker size. There's also a warranty of somewhere between 5 to 10 years and up to 6,000 cycles. When they say 6,000 cycles, we'll probably talk a little bit about this, but I just want you to know that normally it's 1 cycle a day is normally how they get that down. So 365 cycles in a year, because there's roughly that's the days in the year. So it'll actually handle, it's about 12 to 16 years is what they say on the battery life. So just past the time the warranty expires, if it's 10 years, about 12 years. So they're gonna have to be replaced about every 12 to 16 years. Hopefully by the time they need to be replaced, the price of the batteries will have gone down even more and there'll be more options. Usually when the price goes down, it's due to more competition and better technology, things like that. So you can figure you're going to replace them after about 12 years or so. So there's 2 types of battery management systems. There's the LFP 5 and 10 and the eVault and the EFlex. So both of them they do have overcharge and deep discharge protection. We don't want to overcharge them. We definitely don't want to drain them down too far. We only really like to take those batteries down to about 20%. And we've got a couple charts that'll kind of discuss some of the degradation and charge rates and things like that. But there is overheat and low temperature protection on both, overcurrent protection, short circuit and open circuit protection, cell monitoring and balancing. And then on the eVault and the EFlex, you also get communication with the inverter, communication between the unit and the panel, or units in parallel, and remote monitoring. And then there are 2 different types of cell types. There's the LF5 and 10 is more of a cylindrical, and the eVault and the EFlex are prismatic. This is basically the 18.5, the LCD display. So it'll let you know what the high voltage is, the low voltage, the highest temperature, the low temperature, and whether you've got an open circuit or a short circuit. So it'll actually tell you a little bit about what's going on and record that info so you can plug into it and get that information as well. Kind of monitor different things that are going on with the array. Battery technology comparison. So the Fortress Power, again, it's a lithium iron phosphate battery, which is a lot safer than the lithium ion or the nickel magnesium cobalt or the lithium polymer or the LiPro. They're eco-friendly. They do have good thermal stability. And again, the life cycles is a lot greater than the LG, the Tesla, Panasonic. So we get about double from the Tesla batteries, a life cycle rate. And then the degradation rate is less than, on the Fortress batteries, is less than these lithium ion or nickel, magnesium, cobalt, and the LiPro as well as the energy density.
On this one, John, this is just this is more of a competitive understanding, because Tesla, pretty well, is the big name, and that's what everybody wants right now. And with that product, it's engineered to be light, which is Tesla's a battery manufacturer, and you can't blame them for wanting to keep their SKUs low. And so they've chosen the cobalt style, and because it's lighter, and obviously and then to be hang on the wall, but with cobalt, it's actually flammable. So if anything were to penetrate that battery in a garage, a car, or whatever it may be, then the battery will, I guess I'll say, will be flammable.
Yes.
Whereas the iron phosphate will not be flammable. So well, there you go. That's the next slide. And then, so these are just all things that we've thought about, and we wanted to offer a product that is best suited for our customers and the circumstances we sell in, which is more residential. So that's why we're going for iron phosphate products.
Yeah, there's actually a video online, you can check it out. But it's just showing that lithium ion phosphate battery, the Fortress battery on the left, and then the nickel manganese cobalt, or the Tesla, and just drilling through it. And you can see on the right what happens when you penetrate that battery. It's gonna cause a slight thermal event, let's put it that way. That's what we like to call letting the smoke out of like a lockout board or anything in tech support. We don't like to call it a fire. We like to call it a thermal event. Homeowners get a little scared when you start talking about fire.
Just got to go to the hardware store and buy more smoke.
That's right. It's really hard to get that smoke back in those boards too, by the way. So temperature impact on the performance of the batteries. So, as the temperature goes up, the voltage is going to go down, and the capacity of the batteries. So we do have a temperature range of 10 degrees Fahrenheit to 110 degrees Fahrenheit with a 6,000 life cycle. So we get out of those ranges, and it's really going to affect the discharge rate, and really it could affect the life cycle rate if it's in that environment, continuously. But we've got a pretty good range. I mean, 10 degrees to 110. That's better than the Tesla batteries, which are 32. They do go up to 130, but 32 is when they start getting a lower discharge or capacity rate on those batteries. Life cycle versus depth of discharge. So obviously it's going to extend your life cycle if we don't drop it, too low. As you, let's say, we drain these batteries down to 20% every time. Well, you can see that's not even on the chart. So it's really going to affect the life cycle of that battery. So normally we're going to depth of discharge down to 80%, and we can normally get about 6,000 life cycles out of that at the 80% discharge rate. Obviously, 100% discharge rate, we're going to have 0 life cycle on it. If you only want to use half your battery, then you can see you're going to be way out at 14, 15, 16,000 life cycles if you only drain those batteries down 50%. So, if you can, we definitely don't want to discharge the batteries any more than 80%. So there's only 20% left in the battery. We don't want to go lower than that. If we can go higher than that, that'd be great. So the only thing that's going to do is just extend your battery life. And that's what this is showing, is the depth of discharge and your battery life. They're going to go hand in hand. Lithium these lithium batteries are used especially in commercial because of their safety factors. Again, they're not going to explode if they get hit. Let's say, this is in a warehouse or something and a forklift comes through and punctures one of the batteries. It's not going to cause a big explosion in their building, a lot safer. You can also rack them just like they've got here. These are actually on wheels, so they can be rolled around. You can see they got a little screen on the front of the batteries in the lower right corner there. So you can access the display screen and see kind of what's going on. You can see in this example, they've got 2 inverters and it looks like about 6 or 7 batteries there. Comparison of some of the different battery technologies. We kind of talked about this, but basically the energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifetime. So basically you can figure that out by the capacity, the nominal capacity multiplied by the depth of discharge, by the efficiency and the life cycle. But it's just kind of letting you know, look at some of the, you can see like the cost per kilowatt on the Fortress batteries. We got 14 cents per kilowatt, and it's cheaper than all the others. Nickel iron is probably the closest, but we got good safety. It's maintenance free. So just some of the efficiencies and life cycle rates. You can see the nickel iron does have a higher life cycle, but you get into efficiencies and maintenance and things like that. And the Coronius battery will definitely outperform that nickel iron all day. Excuse me. Here's the lithium battery versus the lead. The lead acid capacity drops significantly when output current increases. And the LFP battery is basically going to just stay. It's not going to drop capacity as the output current goes up. Space comparison. You can see these are some AGM batteries on the left with the handles on them. So it takes 8 of those batteries to equal 1 eVault. And the eVault will roll around. It's already on wheels. It comes on wheels, so it'll roll around. Again, it's got a display, a user interface with it, so you can look at things and monitor what that battery is doing, rather than just have this little rack. But you can definitely see it takes up a lot less space than that 8-bank battery pack there on the left. So we've got good safety, long duration, probably the highest in the industry that we've seen so far. Low energy cost. I'm guessing, I don't really get into the cost stuff too much. Kyle could probably speak a little bit more about that. And then high throughput. We kind of talked about that with the current and the amps and the degradation. Integrating battery storage into the PV array. So an AC versus DC coupled solution. So here you can see an AC coupled system diagram. You've got your main panel with your grid AC input, and you've got your inverter, your batteries coming off your inverter, your inverter output to your AC backup panel, and then obviously power to the home, and then your PV inverter. So from the right to the left, basically coming back into your inverter, and everything all just ties back into the inverter, and then back into your control panel or your main panel in your home. On AC coupled solutions, when retrofitting to existing PV systems, and for new installations that require module level rapid shutdown. The DC coupled solutions for new installations, no additional PV inverter, and it is more efficient. So you can see the DC coupled system diagram on the bottom there. And this would be for a new installation. You've got your main panel with your grid power coming in, tying into the inverter, and then you've got your solar charge controller tied into the inverter, and then output AC to the home.
Hey, John, on this one, I want to make sure that we concentrate on this slide pretty hard. And just so everybody knows, the Fortress battery setup, along with the Solarc inverter setup, combined, will do either one of these setups, or do either one of these coupling solutions. So it'll do an AC coupled system, and it'll do the DC coupled system. If at all possible, we will always want to shoot for a DC coupled system. And in that case, one thing we could do is, if somebody wants to add a battery down the road in the near future, we could always put them in a Solarc inverter and have them ready to go to plug in a battery behind that. But the AC coupled system, I'll note that it would be a comparison to the Sonnen battery or the Tesla battery, and that does not have any solution for a PV to come into the inverter battery setup. So essentially what you have to do is buy another inverter that is inside of that AC coupled battery generally, and you're having to spend spend money on two inverters when you only need one. So that's why the DC coupled solution brings down the price per kilowatt hour installed, is much cheaper to go that route whenever you combine everything together. If you think about it, we have lots of losses when we switch between AC and DC. So, generally 5–10%, depending on the item. And throughout a home, we jump back and forth between AC and DC, and it also prevents losses, as you can see down in the DC coupled system. So if anybody has any questions on that, please let us know. But the setup, the Solarc inverter and the Fortress battery setup can do either one, but it's best if we can start with a PV coupled system that would be, quote unquote, new construction application. Another note that I'll add that is that microinverters can only, if you have microinverters, you can only have an AC coupled system. And I think that's all I wanted to add on that one.
Okay, thanks, Kyle. Compatible inverters. You can't just choose the batteries and just throw an inverter on it. Right now, I think the only inverter we offer for this battery is the Solarc. Is that not correct, Kyle?
Yep. There's just too many other options out there. And for example, if you look at this chart, there's a few others out there, but there's not that many in the blue that only, that do AC and DC. So that's why we chose the Solarc inverter setup, which is the third line or the third blue line down. And They're available in 12 kW and 8 kW inverters that can be AC or DC coupled.
Yep. Here you can see, here's a total of 74 kilowatt batteries, basically. They have been in operation for 10 years. You can stack up to 4 in the 120 240 volt and up to 9 in the 120 280 volt. So with these batteries, you can do off-grid, time of use, load shifting, backup, grid export. You know, with batteries, there's a lot you can actually do, and you know, a lot of it is as well going to depend on what you're trying to get accomplished with these batteries. So, you know, if you have, you know, you can't sell back to the grid, then batteries are going to make a whole lot of sense. And they're great for backup. You know, they're basically, you can add a generator onto it. They can take the place of your generator using the battery. So, and that's another reason why, you know, we're looking towards the batteries. Basically, they allow for AC and DC coupling. They will perform in hot environments. And it does have auto gen start optional with these batteries. So it'll automatically start your generator if you got a backup generator. Just some technical specs, surge power at backup, storage capacities, stackables, 4 in the single phase, 9 in the 3 phase, and the inverter output capacity. It does have a built-in transfer relay. So it's basically a grid failure transfer switch. And once it sees that, it takes 8 milliseconds to switch it over. So pretty quick. Again, here's just a little, this would probably be more of a little residential setup here. One battery pack with the solar converter right on top of it. Again, on this, you can stack up to 3 in the single phase and up to 6 in the 3 phase. You have 10 to 222 kilowatt storage capacities. It's about 93% round trip efficient. So from the solar panels to the battery to the load, you're only going to lose about 7% of the power. Again, it's got the auto gen start included, allows AC/DC coupling, and it's an all-in-one unit. So again, you can use it for off-grid, time of use, self-supply, backup, and grid export. Just some more technical specs, AC output and power, your different storage capacities, your surge power, critical load panel, amp rating, response time, grid tie to off grid for 4 milliseconds, and the PV array size up to 13 kilowatts in DC coupling, and up to 7.5 kilowatts in AC coupling. And compatible PV inverters in AC coupling, Solar Edge, Fronius are a few that we have ourselves, that we actually sell the Fronius and the Solar Edge inverters. AC and DC coupling combined a total of 13 kilowatts max. And again, stackability, 3 in single phase, 6 in 3 phase, 3 units per phase. And there's a 10-year standard warranty on that as well. Here's basically the system wiring. So you have your battery terminals, your PV inputs, your AC load out, your grid in and out, and your gen input or your AC coupling input. So it's really not too difficult to wire up, pretty straightforward. Here's a bigger wiring schematic, a little bit more of a layout here. You got your battery disconnects, your PV rapid shutdowns with the disconnect, the PV disconnect, and then your load outs and that kind of thing. You want to take a look at this when you're installing these. It's a pretty good little diagram for your wiring up of the batteries and all that. Integrating midnight or string level rapid shutdown. Make sure that the rapid shutdown is located near the grid meter. Rapid shutdowns for emergency purposes, obviously, it's like basically a disconnect to shut everything down. So if there's a fire or something like that, the fire department can come and cut it off pretty quickly. You've got your switch conductor, you've got your string of panels. On the upper right is your inverter. And you've got some transmitters that will clamp on and will broadcast out to your receivers, kind of know what's going on there. Any comments on this, Kyle?
No, I don't. No, I don't think so. You're doing a pretty good job on it.
Okay.
Yeah.
Integrating TIGO for module level rapid shutdown. So here you've got your little Cloud Connect CCA. There's your inverter, your smart modules, and then your access points.
This is the Fronius and, for example, SMA, Solarc are all standard string inverters. And you have to add rapid shutdown to those inverters. You're at an option or a company that makes a rapid shutdown solution. It's called TIGO, and this is just some of the products that they make if rapid shutdown is a requirement for your area.
Design guide for the PV and storage. So Fortress Energy Storage sizing tool. It's I think it's PVwatts is the email or something. It may be here in just a minute, but basically it automatically sizes your up energy storage for backup. So the first step you're going to do is you're going to select the loads to be moved from the main panel to your backup panel. Then you're going to calculate the daily usage of your backup load panel, then which will in turn select the battery bank size and also estimate the daily power available. So we can go in there and put in some information. I was just working with Angelique last week on one that she was trying to figure out the batteries for, and just kind of discussing what had to be done. This is the PVwatts calculator from the website. So here you can go in and you can look at, let's say number one is essential, and it's not really going to be a refrigerator or a freezer. Maybe, I don't know, maybe it's a sump pump or something. But you can click on, normally when you go to the website, you can click on this refrigerator, freezer, Energy Star. There'll be a little drop down, and you can open that up. Oh, sorry. You can open that up and you can choose different. If you had a, let's say it was a refrigerator, but it wasn't Energy Star, you can put that on there and it'll spit out some numbers, you know, your starting watts, your running watts, and hours a day. And for some reason, yours is different than what's shown here. You can always adjust these numbers to the right of what the item is. So that can be adjusted, but you'll have to put in all of these. As you change these numbers, then it's going to change the quantity of inverters, and your surge power and your running watts will all update as you put more and more things into the items list. So this will have to be filled out. If they want battery backup, this will have to be filled out with the homeowner, discussing what their which circuits are going to be needed, which ones are for your backup. So this could be a little bit tricky. This is kind of what Angelique could run to a little bit of, it wasn't a huge issue, but we kind of discussed, yeah, we've got to bring the homeowner and the dealer into this conversation and have them fill out this form. We can get you a link, or we can, walk through it on the computer with you, but we have to have this filled out in order to figure out how many batteries we're going to need, how many inverters, and what's available. So monthly PV or day production and energy available to charge the batteries. You're also going to have to look at your power consumption on your power bill to get your normal energy per day that you're using. You also have to remember that the available power in the battery, normally we're going to have a 90% pull from that battery. Then we're also going to take into consideration the lowest average daily available PV power and the highest average daily available power. So, and with this, it'll actually tell us with these numbers down here that we can expect 0.9 days of battery. So almost 1 day of battery backup is what you're going to get out of it. You're not going to have, yes, you could actually figure out and get, put more batteries in, but it may not increase the amount of days that you're going to have, because you can only bring in so much power from the sun in your PV array, and you can only charge your batteries so much as well. So we're really not going to get above a whole lot, maybe 1.5 days at the max, I would say, but we're probably not going to see this as like 7 days or, a week of battery life. This is not going to happen. This is an example here of a 9 kilowatt PV array and a 9 kilowatt 20 kW battery. So we need to just make sure when we're designing these batteries that we get a power bill and that we figure out, again, this chart here. It's going to be pretty imperative. And then once we get this chart filled out, there's another sheet on the Fortress website where it will then again tell us, okay, you need this many inverters and this many batteries to handle, a day of backup battery. So if you need batteries, definitely contact design team, because we're going to have to go through design. Well, with any type of solar, really, to be honest with you. But if we want battery backup, definitely give Angelique or Jeremy a shout, and we'll get you to this form and figure out batteries and inverters and that kind of thing. So with that, I don't really have anything else. Make sure you get a power bill with that. And that'll definitely speed up the process of designing and making sure we've got enough batteries and the right inverters and that kind of thing. So
a copy of the power bill is critical on that. Just a full printout of the actual bill itself. That way we can see the structure of the bill. And it's important to see both, the 12 months usage, but also the PDF copy of the bill, if at all possible. Otherwise, we can't really see how the bill is structured to see if batteries make sense or not. Does anybody have any questions or anything like that they want to like for us to answer? Okay. Well, and there's another tool that we are starting to use. It's $150 a month, and it's called the Energy Toolbase, and that is a financial design tool. It's not a layout tool. It's a financial tool to be able to tell it takes complex equations with batteries and utilities and helps us apply them so that we can properly apply depreciation, for example, or time of use rates, so that we can plug in the data from the batteries, the inverters, and the PV array to see what is going to be the best case scenario for the consumer. So not only do we have the Fortress battery calculator here that John's provided to us today, but we also have Energy Toolbase subscription, and we're just beginning to learn that. So if anybody would like us to put a design through there, we can do that as well. And I think that in short time, you'll see us start to use that tool more and more and provide that as a return on investment sheet as well. So anyway,
Do you have, they may want to know, Kyle, just off, just for a little bit of insight of how much are the batteries? How much are they going to be looking at?
You're probably safe to say probably $1,000 per kilowatt hour, around there. And so that, if we take 18,000 in this case, it depends on the size of battery. So if you take 18.5 for that Eco Link, or that Inco battery, or I'm sorry, what was that one called? The eVault battery times 1,000, then we're looking at 18,500 for that battery plus the inverter, and then we have to add on the PV to that. So what we've seen in a competitive scenario is that another AC coupled battery costs about the same or more, and doesn't have PV capabilities. So as you start to integrate more items to the project, obviously just like anything else, but the price starts to come down. The price will be higher whenever we use smaller batteries, though.
We had another question as well from Lester. He asked, when batteries start to fail in a bank, do all batteries have to be replaced? And will the new batteries be affected by the old batteries if you don't change all the batteries?
That's a great question. They operate independently. But it's just kind of like re-roofing a house. If you already, I would think that at the time that it's time to replace, that you're probably going to be best off replacing everything, because you're going to be incentivized to do so. So like I was referencing about a house, I mean, even if the one side of the roof isn't good anymore, you may as well just go ahead and replace the whole thing. And that's kind of what I'm referencing whenever you're stacking batteries like that likely when there's an issue, it's going to be a long time down the road, and you probably are going to be better off to just replace them all. But I mean, that's kind of looking at a crystal ball and having an opinion, but that's not actual facts for what the future may hold.
Okay, thanks, Kyle.
All right, well, that concludes 6 of 6 webinars for us. And moving forward, we're going to give a few weeks off, a couple weeks off, but we're going to be bringing in manufacturers from here on and letting them present to us. So we'll host similar to what Carly has been doing for the webinars, and then the manufacturers will be training us on their products specifically. So this series was to get our toes wet in the water, and then we'll bring in the manufacturers to actually give us specific trainings. So we don't have anybody specifically lined up for a date pinned yet, but we will be announcing some updates from like Iron Ridge and the battery company, or Fortress rather, Solarc, AP Systems. So be on the lookout for more trainings in the near future.
And then we did have one final question come in, and just that was the future of the tax credit. Any thoughts? That's from Ken Porting.
Opinions. I think that would be probably a Steve question, but that just depends. Everybody feels like it's going to come back to 30% in the near future, and likely before the election is what I've heard. And I think that that's what we're going to likely see, but I mean, not really sure at this point. I mean, especially with coronavirus. But I did hear that I think, what is it, the Senate going or back into session May 4th. So it just depends on how things go. But we are, I think I'm confident to say that in the near future, we will have the tax credit reinstated. We just don't know yet as to when. But another comment would be that maybe coronavirus was good to bring it back because the potential loss of jobs. So you never know. And in my opinion, it's coming back, I would say within 12 months, but that's a guess. So we'll see.
All right, I think that's it. Thank you all for your time. Again, if you have any questions, please give us a call, shoot me an email, or whatever works best for you. And hopefully we'll see you guys again soon. If you need some geo training, there's some going on this week, so you can check out our Enertech University site and sign up there. All trainings are free, so definitely check them out. And again, we'll be adding some more manufacturer trainings coming up here in the next couple weeks. So stay tuned, and thanks again